Hello students, in this video I will be speaking about monopolies. What is a monopoly? This is another type of market, different to the one that we were speaking about last class that was perfect competition. So now we have a monopoly. I want to speak also about what is a cartel and what is price discrimination. So first we're going to start with the characteristic of a monopoly. Everybody knows that there is only one supplier in the market when we have a monopoly. And I'm going to call monopoly not only the type of market, but also I'm going to call monopoly to this supplier, to this company. There is only one company in the market that I'm going to call monopoly. So the word monopoly will be used in two ways. One, to symbolize what is the type of market, and also to say what is the only company that is working in this market. So this is only one supplier. So this is the first characteristic. And the second one, the monopoly's demand curve is the same of the industry demand curve. This is obvious. If there is only one supplier in the market, if there is only one company that I call monopoly, so the demand curve of this monopoly will be the demand curve of the market. If somebody is willing to buy something, is willing to buy to this company because this is the only one. And third, there are barriers to entry the market, and that's the reason why there is only one company. These barriers could be natural, legal, or onerous barriers. For example, natural barriers, so the industry demand conditions allow no more than one firm to produce at its minimum efficient scale. Remember, any company tries to produce at a minimum efficient scale. So in such a way that the long run average cost is minimum. Remember, the minimum efficient scale is the point of minimum quantity when we have the minimum total average cost. So it will be for the demand that the new company is going to have is not so big. So the amount that they are going to need to produce is not so big for the cost they have. So they cannot produce at this minimum efficient scale. It's too difficult. So you can imagine a company that is producing the power of the whole city. If there is a new company, only one company producing the electric power of the city. If there is another company that wants to go into the market, they don't have at the beginning so many customers. And they need to have a lot of cost. The cost needs to be a lot to put the cables to the whole city, to make the infrastructure for the whole city to produce the power. So it's gonna be too cost. The cost it will be too big for the quantity produced. So the long run average total cost, it will be too big for this company. So that not allow another company to go into the market. And there are legal barriers. And obviously, and that happened that the government can't introduce legal actions for new companies to go into the market. For example, patent law allow only the patent holder to produce a particular good during a specific period of time. There will be a period of time where this patent law is in effect and another producer cannot be in the market. This will be a legal barrier. But also, for example, here in Toronto, a few years ago, there was a monopoly for selling alcohol. So LCBO was the only company that was a government company that was allowed to sell alcohol. So it was illegal, so the government made illegal another company to go into the market. So that could happen. So there are barriers to go into the market, and that's allow only one. It's very difficult that in the new world appears actually a monopoly, a real monopoly. But if that happens, or if we are close to a monopoly, is because there are natural barriers or legal barriers for other companies to go into the market. The demand of the market, it will be the demand of the monopoly of this only one company that exists. And I'm going to speak about the relation that are between these three variables, the demand, the average, and the marginal revenue. But assume that this monopoly face this demand. So when the price is 10, there are no customers that want this. So when the price is 10, the quantity demanded is 0. But assume that they drop the price. The price is 9. Then the quantity demanded is 10. If the price is 8, the quantity demanded is 20. So it's going to happen the same that was happening in whatever other market. The lower the price, the higher the quantity demanded. And if we have this, we can make a graph so of the demand, at least of the demand at this moment. So we have the price, remember, in the y-axis, the quantity demanded in the x-axis. So if we make the graph that we have there, so we're going to have a straight line like this. That's always the demand curve is going down. In this case, it's a straight line with negative slope. So the demand, as always, have a negative slope at any point. And in this example, we have a straight line. This is the demand curve, and if we want to compute the marginal revenue, remember the marginal revenue is the change in the total revenue divided by the change in the quantity. So if we want to compute the marginal revenue, what we need to do is just divide the change in the total revenue divided by the change in the quantities. So let's compute the total revenue before computing the change in the total revenue. So let's make another column and multiply, and so obviously to compute the total revenue, we multiply the price multiplied by the quantity demanded. And I understand that if the quantity demanded is 0, when I multiply by the price, the total revenue will be 0. So in this case, it will be 0. But in this case, 9 times 10 will be 90. Or 8 times 20 will be 160. And obviously, I'm multiplying the price, multiplying by the quantity demanded. But this quantity demanded will be the quantity that this company can sell, because it's the only company. So if there are 20 units demanded, the company is going to sell 20 units. But if they are only 20 units, it's because the price was 8. Because at a different price, they will have a different quantity demanded. So when the price is 7, it's 210. When the price is 6, the quantity demanded is 40, and then the total revenue will be 240. And then in this case, it will be 250. But if they want to sell more, there will be a moment when the total revenue is going down, even if we have a monopoly. Yeah? So for example, in this case, the price is 4. To sell 60 units, the company needs to draw the price to 4. So it will be 4 times 60, the answer is 240. So now it's lower than in this point. So the total revenue have a maximum. And the maximum is when the price is 5 for this company. Here is 3 times 70, 210. 2 times 80, 160, and etc. If they continue dropping the price, the total revenue is going down. 1 times 90 will be 90, and the last situation will be when the price is 0. In this case, the quantity demanded is 100. So if this product is free, the quantity demanded will be 100, no more. So this city don't need more of this product. So even if the price is 0, so the quantity demanded is 100. So at that point, obviously, the total revenue will be 0. The total revenue for a monopoly will be going up, and then we have a maximum, and then going down, because if a monopoly wants to sell more, need to drop the price. And it will be a moment when the price is so small that then the total revenue start going down. Okay, so we have that the total revenue satisfies this. What happened with the change in the total revenue? And because we are going to be speaking about the change, and the reason is I'm going to compute the marginal revenue. I'm going to compute the quotient between the change in the total revenue and the change in the quantity. So here, the change in the total revenue is $90. So it will be 90 here. The change here from the price is 9 to 8, or from the quantity demanded 10 to the quantity demanded 20, is from 90 to 160. The exchange is 70. Assume that this is dollars, so it will be $70. So this is 70. Now the change in the total revenue is different. And the change, when the quantity demanded changed from 20 to 30, the change in the total revenue will be 50. And you can continue. The change in the total revenue here was 30, here the change in the total revenue was 10, but after that, the change in the total revenue, remember the change is the last amount minus the initial amount, will be 240 minus 250, and you notice that it's negative 10. So it will be here negative 10, here will be negative 30, and start going down. From that point of maximum, the change in the total revenue will be negative until a minus 90 here in the last row. And the change in the quantity is always 10. You notice here we need to divide the change in the total revenue divided by the change in the quantity. So we are ready to compute the marginal revenue, the change in the total revenue divided by the change in the quantity. So it will be 90 divided by 10, and always divided by 10, but in this case, what in the schedule that I have, the change in the quantity demanded was always 10. Do you notice? So I divided 90 divided by 10, so it will be 9 here. 70 divided by 10, 7. 50 divided by 10, 5. And then again, 3. Then 1 will be in this case 10 divided by 10, and after that it will be a negative marginal revenue. It will be minus 1, minus 3, minus 5, minus 7, and minus 9. And we have now the data for the marginal revenue that we can make the graph here. For example, if I notice that when the quantity is 5, when I'm making the graph, this number in the middle between 0 and 10, I assuming that is the number for number 9. So I have the pair 5 in the x-axis and 9 in the y-axis. So it will be here 5 and 9. So it will be this point here. And I notice that it will be a point when the marginal revenue touch the x-axis. After that point here, the marginal revenue start being negative. And that happened in the middle of these two situations when the quantity is, this one corresponds to the quantity 45, and this minus 1 corresponds to the quantity 55. So remember that this marginal revenue is in the middle of two rows. So if I interpolate here, I notice that this 50 corresponds to the 0 here. So this point of maximal total revenue give me a point here in the middle between 0 and 100. I notice that number 50 will be when the marginal revenue change from being positive to being negative. This point is important, but something that you should notice is this point is in the middle between 0 and 100. And 100 is the maximum quantity demanded. If the demand curve is on a straight line, it's easy to compute the marginal revenue. But something important we are learning here, the marginal revenue and the demand are different. In the case of the perfect competition, the company had a demand curve that it was horizontal, and also a marginal revenue that was horizontal. And it was the same. Here in a monopoly, the demand, it will be always going down. It will be a curve that has always a negative slope, and the marginal revenue and the demand will be different for this firm, because the demand of the firm is the same demand of the market. But not only that is the difference, that also the marginal revenue is different. It's now not only equal to the demand. Actually, the marginal revenue is always lower than the price. For example, when the price is 20, here is this 6 will be the marginal revenue, but the price was 8. When the quantity is 40, look at that, these 2 will be the marginal revenue, but the price, you need to look at the price in the demand curve, the price was around 6. So the marginal revenue is always lower than the price. That is very important. If I want to compute the average revenue, the total revenue divided by the quantity. So in this case, you need to divide total revenue divided by quantity. So 0 divided by 0, you cannot do it. Or 90 divided by 10, it will be 9. Or 160 divided by 20, so it will be 80. Or sorry, it will be 8. Or 210 divided by 30, it will be 7, etc. So you can compute the average revenue. So, and you will notice that the average revenue, it will be always the price. So what is equal to the price is the average revenue, not the marginal revenue. In a perfect competitive market for a firm, the average revenue, the marginal revenue, and the price was always the same. Here what is the same of the price is the average revenue, but the marginal revenue will be always lower than the price. So the demand curve is going to give you a curve for the average revenue. Obviously, because the demand is giving you the relation between the quantity demanded and the price. And this is exactly the average revenue. As a conclusion, we say that the marginal revenue is less than the price, and this is because to sell an additional output, the monopoly need to lower the price. So P need to be lower to raise the quantity demanded. Okay, so this will be important for the thing that I'm going to say now. If we have a demand curve that is a straight line, so the function of the demand curve is P equal A minus B Q. Q is the quantity demanded. This A is the intercept with the y-axis. This is the price when the quantity demanded is 0. And this B is the slope, so it's going to be negative. So if we have that is a straight line, then the slope of the marginal revenue curve will be multiplied by 2, the slope. So we're going to have that the marginal revenue will be A minus 2BQD. You notice that the intercept of the marginal revenue and the demand curve is the same, yes? It will be A times here. But the intercept with the x-axis will be always the half of the intercept of the demand curve. The x-intercept. And you notice here that if I want to know what happened when the marginal revenue is 0, so this A need to be at the other side and you divide by 2B. So it will be the half of this. So always this intercept is the half of this. So if the intercept of the demand curve is 100, and if we have a straight line, by the way, then the intercept of the marginal revenue will be 50. If the intercept here is 120, the intercept of the marginal revenue will be 60, etc. This always is going to happen. We conclude then that the marginal revenue and D has the same y-intercept. And the x-intercept of the marginal revenue is half of the x-intercept of the demand. Again, if we have a straight line as the demand curve. Another thing that we learn from here is that the monopoly is never going to produce when the demand is inelastic. We have a straight line, the demand is unit elastic here in the middle. Below this point, the demand is inelastic. So when the quantity is more than 50, in this case, the demand will be inelastic. And at that point, the monopoly never going to be working at that moment because the marginal revenue will be negative. Increasing or decreasing the price, anyway, the marginal revenue will be negative. So we conclude that the monopoly never operates when the demand curve is inelastic. And the firms are not price takers. They decide output and price. At least until this moment, they decide, no, I don't going to sell to 60, I don't going to put a price of 4. I don't going to sell when the demand is 80 and the price is 2. No, I don't going to sell at this point, in this region. They made at least a first decision with this graph. I'm not going to produce when the demand curve is inelastic. But they can even decide exactly what will be the price and what will be the quantity that they need to produce in order to have the maximum profit. But at the end is what the firms want, a maximum profit. So let's see how a monopolist decide what will be the maximum profit. Remember, a maximum profit always happens when the marginal revenue equals the marginal cost. We know already, we have studied already what happens if the marginal revenue is bigger than the marginal cost, or if the marginal cost is bigger than the marginal revenue. None of these points will be point of maximum profit. the point of maximum profit will be that when the marginal cost equals the marginal revenue. So we need to know about the cost, obviously, to know the profit. In mind that we have this, the marginal cost is this curve here. And we want to decide what will be the profit maximizing level of output. Will be the one when the marginal cost equals the marginal revenue, and just go to the graph and see this point. In this is the marginal revenue, this is the marginal cost. This point of intersection gives me the quantity that the company needs to produce to get the maximum profit. So in this example, the profit maximizing output will be 40. So we have this 40, and then if we want to decide what will be the price, let's take note of this. The profit maximizing output will be 40. So this firm must produce 40 units if they want to have a maximum profit. And obviously, if I know that the quantity is 40, I can go to the demand curve and notice that this quantity 40 is achieved if the price is 6. So I go to the demand curve to see what will be the price that this monopoly need to have to get the profit maximizing output. So this price will be then 6. A profit maximizing monopolies have a price greater than the marginal cost. In this case, the price will be 6. So this firm imposes a price of 6 in this product. And if I want to know what will be the profit, I need to have information about the total cost. But so far, I know what will be the quantity that gives me the maximum profit and what will be the price to have this maximum profit. So if we have the average total cost, then I can compute what is actually the profit, or the economic profit, I'm going to say. That is the maximum possible profit. The maximum economic profit, remember that this is total revenue minus total cost, and the profit maximizing output, QM. So it will be the price times the quantity. This is the total revenue. So you multiply this, you get the total revenue. And if you multiply the average total cost by QM, that gives me the total cost. So if you multiply the average total cost multiplied by the quantity, this is the total cost. You can get here common factor. You have a formula for computing the maximum economic profit. So the price minus the average total cost multiplied by QM. This is this area in blue. This is the profit. So you can see this area in the graph. This area gives you the profit of this monopoly. Let's see other examples. Yanni Soda, a single price monopoly, faces this market's demand and total cost schedule. And we want to know at what price is Yanni's total revenue maximized. First. Second, calculate Yanni's profit maximizing output and price. In this schedule, we have the total cost, we have the quantity demanded. If this company is producing 0, the total cost is 1. So it means they have a fixed cost of 1. When the quantity demanded is 1, the total cost to produce this quantity will be 3, and etc. So we have aquí the total cost. The total revenue will be the price times the quantity. In this case, price is 10, the quantity is 0, the total revenue is 0. If the price is A and the quantity demanded is 1, they are going to say this will be A times 1, this will be 8. So etc. So it will be 0A, and then 6 times 2, 12. Here 4 times 3, 12 again. And now it's going down. 2 times 4, 8. 0 times 5, 0. So we have the total revenue. If the question is just compute the maximum revenue, okay, the maximum revenue, it will be when they are producing between these two numbers. Yeah? The total revenue is 12. And here again, the total revenue is 12. The total revenue will be the maximum in the middle of these two numbers. These are the maximum so far, but I noted that here we don't have all the data, but I noted that the maximum revenue will be between these two numbers, between the two maximum that we have so far. So the maximum revenue will be here in the middle. This is when the price is 6, this is when the price is 4, so here interpolating, so the one in the middle will be 5. So I can answer the first question. The total revenue is maximized when the price is 5. This is not what the company wants. The company doesn't want to maximize revenue, want to maximize profit. So I can answer that the Yanni's revenue is maximized at the price of $5. So this answers the first question. But the second question is more interesting. Calculate Yanni's profit maximizing output and price. that will be when the marginal revenue and the marginal cost are the same. So let's see, the marginal revenue in the first one, the total revenue is 8 and the change in the quantity is 1. Remember, marginal revenue is change in the total revenue divided by the change in the quantity. And it's written here in the middle. 8 divided by 1 is 8 here. And then will be 8 to 12, it will be 4 divided by 1, 4. Then here is 0, so I get the maximum at that point in the middle of this. So it will be the maximum here at 5. When the marginal revenue is 0 at that point, we have the maximum. And then get down, so it will be from 12 to A, it will be minus 4. So it will be A minus 12. Remember the last amount minus the initial amount. It will be A minus 12. So it will be negative 4. And this will be 0 minus A is minus A divided by 1 minus A. So we have the marginal revenue here. And the marginal cost will be the change in the total cost divided by the change in the quantity. From here to here, the change was 2. From 1 to 3, the change was 2. 2 divided by 1 is 2. Here, from here to here, from 3 to 7, the change is 4. And I know immediately what is the answer. From 7 to 13, the change was 6. From 13 to 21, the change is 8. From 21 to 31, the change was 10. So that's are the marginal costs. And I know here when the marginal revenue is negative, that's the moment when the demand is inelastic. The company is not going to work at that point. But the company is going to work when the marginal revenue and the marginal costs are the same. And that happened exactly in the middle of these two. When the quantity is actually 1.5, in the middle between 1 and 2, do you notice that this 4 is in between, in the middle between 1, when the quantity is 1 and the quantity is 2. And this is when the price is between 8 and 6, so when the price is 7. Then I can conclude that this point is the point when the marginal revenue and the marginal cost are the same. And that happened, I go here to the quantity and the price, and that happened when the quantity is 1.5 bottles per hour. You can produce 1.5 bottles per hour, yeah? Why not? And when the price is $7. So let's answer this. That the marginal cost, in this case the marginal equal the marginal revenue, and the Yanni's profit is maximized at the price of $7. So here this 4 is in the middle of 8 and 6. And the quantity is around 1.5 bottles per hour. Okay, and this answers this problem. So imagine that we have this firm that faces this market demand, this marginal cost, and faces this average total cost. If I want to know what is the profit maximizing output, it will be a good idea to have the marginal revenue. So I'm going to draw the marginal revenue curve. So I want to see what happened with the revenue when there is a change in the quantity. For example, when the quantity changes from 0 and 20. When the price is 240, the quantity demanded is 0. But when the price is 200, the quantity demanded is 20. So I can use this for computing the marginal revenue between these two. And I also can notice that intersection between 0 and 120. I can go here in the middle to 60. So for sure the marginal revenue will be here in the middle, 60. So it will be the point 0.60 for sure in the marginal revenue. And at that point, when the price is 40, the quantity demanded is 100. But the marginal revenue will be the middle. It will be 50. So it will be this point here. Wow, the marginal cost will be exactly the same. And for example, when the price is 200, the quantity is 20 in the demand, yeah? But in the marginal revenue, the quantity will be the half, so it will be 10. So I know that it will be 210. And 160, here will be in the middle, 160, the quantity will be 20. And for 120, so I notice that the quantity demanded is 60, but for the marginal revenue will be 30, etc. So I can draw this curve easily. And the second question is, what is profit maximizing output and price? And as the third question, I'm going to compute the fair economic profit. So obviously the fair economic profit will be that profit that they have when they are producing in the profit maximizing output, and they have the profit maximizing price. So let's make the marginal revenue curve. I already told you what to do. The quantity for the marginal revenue will be the half of the quantity demanded for each price. If we have a straight line, and here we have a straight line. So this curve is easy. Now see where is the intersection for answering question 2. What is the intersection between the marginal cost and the marginal revenue? And I noticed at this point of intersection, the quantity demanded is 50, and they are going to produce 50. And to get the price, go up until the demand curve. And when you go up, you're going to get a point in the demand curve that gives you the price, that the price was 140. So you have then that the profit maximizing price is 140 and the profit maximizing output is 50. So you can answer question 2. So the profit maximizing output is 50 units and the profit maximizing price is 140. And now that you have this, you can compute the firm economic profit. It will be this area here until average total cost. So it will be 50 multiplying by 140 minus 80. You can use this formula. Profit maximizing price minus the average total cost at that quantity multiplied by the profit maximizing quantity. So it will be 140 minus 80 multiplied by 50. So that gives me, this is 60 multiplied by 50, and that was 3,000. So that will be the maximum profit, and obviously this is the economic profit. That is this area here. What I'm going to show you now is why a monopoly is inefficient. So if this were a competitive market, the marginal cost, remember, is the supply curve. So we're going to have a supply curve. But the monopoly doesn't have any supply curve. So they are willing to produce exactly one amount. And this is the amount when the marginal cost equals the marginal revenue. But if this were a competitive market, this will be the supply curve for the whole market. The marginal cost of all the firms together is going to produce the supply curve. And the demand curve will be the same. And I know that this will be the equilibrium point of the market. That point will give me the price and the quantity in this competitive market. So the 70 will be the quantity exchange in this market. And the price of the market, of this competitive market, will be 100. And this will be the surplus of the market. That will be the economic surplus, the market surplus. All this area here, remember when we studied the market surplus? So it will be all of this. So this will be the competitive market surplus in a perfect competitive market. But because this is not a perfect competitive market, actually what we have is that this is only one company, and this company have a marginal revenue here. And the profit maximizing output will be here. So we are going to have that the market surplus will be smaller. So this is actually the quantity exchange for the monopoly, and this will be the price. So it will be a higher price and a lower quantity exchange. So this will be the price in the monopoly, bigger than the price in the perfect competitive market. And what is worse is that the quantity exchange is smaller in the monopoly than in the perfect competitive market. So this is the actual price of a monopoly, and this is the actual market surplus in a monopoly. So we have here a deadweight loss. So we have lost something in this market. Okay. Now I'm going to explain what is a cartel and what is the effect of cartels in competitive market. Assume that this is a perfect competitive market, and I know that this is the marginal cost, that I know that this is the same supply curve. And here we have a point of intersection that gives me the quantity exchange in this competitive market and the price in this competitive market. Assume that we have this situation. But a cartel happens when several firms in an industry work together to maximize joint profit. They are going to work as a monopoly. Because if they work together as if they were only one company, they know that they can produce at this point. Remember that in a perfect competitive market, at this price and at this quantity of exchange, the profit is zero for each of the company. If they join together and work as only one company, they can produce lower and the profit will be bigger. So they work as a monopoly. They made the marginal revenue curve of all the curve together, of all the firms together, and find the intersection between the marginal cost and the marginal revenue. So if they work as only one company, they can have a marginal revenue curve as they were a monopoly, and then produce at that point. So if they work together, that will be the quantity of maximum profit, and this will be the price of a monopoly. So they are going to work with the price and the quantity of the monopoly. And now they have together all this profit. Now the profit is not zero. So now we have a higher price and we have a lower output. So the market is losing. Now the surplus is lower. But it have another effect, because members have an incentive to cheat. And I'm going to explain now why they have an incentive to cheat. If one of the firms cheat in this collective agreement, this firm can get more profit than what they are getting at that point. So I'm going to explain this with an example. So assume that we have 10 firms that are going to form a cartel. This is the marginal cost, this is the demand curve, and this is the marginal revenue. They working together as only one company. So the profit that they have is positive. Now is not the zero that they should have. And this profit is divided in several companies. So this is if I see all the 10 companies working together. Now what happened with each of the company? So this company have a marginal cost, it have an average total cost. So now all the 10 companies are producing 50 units. But if the 10 companies are the same, each of the companies are producing 5 units. So we have here 5 units. Here the y-axis is exactly the same. The prices are the same. This firm is taking the price from the cartel and using the price. If this firm doesn't cheat. So if they have a profit, so this profit, for example, in this case, where the quantity was 50, so for the 10 firms, so this firm is producing 5. And if this were a perfect competitive market, the quantity exchange will be 70 and the price will be 100. So imagine that we have 100, and this is what is happening in a perfect competitive market. The average total cost will be here. So the profit is zero in a competitive market. So we know that. But they are not selling at that price. They are selling at 140. The cartel choose this price 140. And now they are selling at 140 and they are selling only 5 units. And this is a firm that is not cheating, but this firm is getting now profit. So the profit will be 120, for this company will be 140 minus 120 and multiply by 5. So this area here is giving me a positive economic profit to this firm. So this will be the profit without cheating. But this firm can produce here. The marginal revenue and the price in a competitive market are the same. I know that the marginal revenue of the market is this, if they work together, but if this firm cheat, if they choose the price, now they are going to work as in a perfect competition. So now the firm is a price taker. And in this situation, the marginal revenue and the price is the same. The demand curve for this firm will be this line here. And when the price and the marginal cost is the same, this is the point that gives me the maximum profit for this firm. In this case, for example, you can see now that if they sell 8 units, the profit will be bigger for this firm. So now this is the quantity that is going to produce if the firm is cheating, and the profit will be bigger. So will be this amount. There is an incentive of each of the firms to produce more. And for that reason, the cartel is not stable. so the member has an incentive to produce more. Now I explain what is price discrimination among unit of output. The first know the demand curve, but the first would like to know what will be the price that everybody is willing to pay for the product that they produce. They know that if this is the demand curve, there are actually, imagine that every person buy 1 unit, just to speak in this way. 20 people are willing to buy at this price, 200. If they know this, that there are 20 people willing to buy, the demand when the price is 200 is 20, they would like to know what are these persons, because maybe they sell this to this person. So the firm practice price discrimination among units of output if it charges different prices for different units of a product. For example, the service of transport here, the public transport here in Toronto, they charge a value for the young people and another value for the students or maybe for the seniors, for example. So they have different prices for different sectors of the market. If they know what sectors are willing to pay some amounts, they are going to practice this price discrimination. By doing this, the firm is trying to capture some consumer surplus. What I'm showing you here, this rectangle here, is the economic profit of the firm. And the triangle that is here at the top of the price, remember, this is the consumer surplus. So we have here a consumer surplus. But when the firms charge different price, the other prices will be higher than this price. For example, for these 20 people charge this 200. So the firms is capturing this surplus. So now this will be part of the profit of the firm. And if they know different sector of the market, then they're going to charge different price to each sector. And the more prices they have, the more they capture from the consumer surplus. So now the profit of the firm will be all this rectangle here. So if you want to compute the profit of the firm that is charging all these prices, what you need to do is just get all the area that we have here shaded. Assume that a firm with market powers, or market powers means that can choose the price, that faces different demand curve in different segments of the market. So they have different segment of the market, let's say seniors and young people. Let's say two. And they have different demand curve. So the seniors, let's say this second one is for seniors and this for people working, young people is this. And this is the question, what will be the fair profit maximizing policy? If they have these two demand curve, and I noticed that this is more elastic, so if we change the price, the change in the quantity is bigger here. The senior doesn't need to go to work, doesn't need to go to study. If they raise the price to the TTC, too much for the seniors, so they are not going to go out of the houses. They are not going to use the service. They don't need it. But here in this case, we have the demand is less elastic. It's more inelastic, this demand curve. So it means that if you raise the price, maybe there is a change in the quantity, but not so big as here. So obviously, if we are going to choose the price of this, I'm going to choose this point. So that will be the quantity, and this will be the price. And the distance will be bigger now, because now this is more inelastic. Yeah? So the slope is bigger here of this. And in this case, this will be the marginal revenue, the marginal cost, it will be here. And you notice here that the price will be smaller in this case. So the answer of this question is that the less elastic the demand, the higher the price. So obviously, it will be higher the price for young people than from the seniors. That if you change the price, the change in the quantity demanded will be really big. Here in this case, if you raise the price a little more, the change will be smaller, the change in the quantity. Okay, and this will be the firm profit maximizing policy. Charge a higher price if the market is less elastic. The less elastic the demand, the higher the price. Okay, and with that I conclude my explanation of what is a monopoly, what is a cartel, and what is price discrimination. I hope you have found this useful. Thank you.